Hello guys, welcome to H2O, the A to Z of chemistry. I'm Dr. Ritu Johar and I will be your educator for this course on hydrogen. So this is going to be a crash course on the topic of hydrogen for the various competitive examinations like NEET, JEE Mains and JEE Advanced. And how are we going to prepare hydrogen? Well, what we are going to do is that we will be putting two lectures for you on hydrogen, and these are going to contain multiple choice questions. So it is going to be a learning only with multiple choice questions, and these questions, they have been chosen in such a way to provide you an understanding of all the questions which are asked from this topic in the previous year JEE Mains Advanced NEET examination. And also, while we will be discussing these questions, we'll try to cover the most important points from this course, and as it is in the form of MCQs, this will make the learning interesting. And when things are interesting, when they can be learned and remembered in a better way. So now the questions they are going to be in this lecture, they are the same questions which we have also put in the lecture review questions in our detailed course on hydrogen. So we at H2O Chemistry have a detailed course on hydrogen also, and there at the end of each lecture we have put these MCQs as lecture review questions. We cover a topic and then we ask you the questions and ask you to put the answers in the comment section, right? So all that information which we are going to discuss in these lectures of ours on the course hydrogen, that all content is available in our course. So while we are discussing these MCQs, you can make your brief notes, but in case you want detailed notes on the course hydrogen, you can just go back to our channel, subscribe to the channel, see all the available playlists, and from that choose hydrogen. And also here I would like to mention that the students who want to have the same course in Hindi voiceover, that is also available. All the courses at H2O Chemistry, they are available in English and Hindi voiceover. So whatever suits you, you can choose that course. Now, while we are going to discuss all these, we will be trying our level best to cover the important topics from the NCERT textbook, and also we will be trying to give you the questions which are going to be important for your competitive examination. So the content which is extra than the NCERT textbook, that also we will be covering over here. So let us begin this 2-lecture course on hydrogen. So the first question which I have is that the element which has no neutron is, so this is just going to be an introductory 5 questions which are going to be also there in lecture 1 from the course hydrogen. Okay, so the first 5 questions, they will be dealing with the topic that we have covered in lecture 1. So again, I'm telling you, whatever we are discussing over here, all the points, they are given in that detailed course. So you can go back and watch those lectures if you want the detailed notes. Fine. So the element which has no neutron is, the choices are hydrogen, oxygen, boron and helium. So hydrogen has the atomic number 1, it has mass number 1. Therefore, what this means is that hydrogen has 1 proton, 1 electron and no neutron. So the only element in the universe which has no neutron is hydrogen. There is no other element in the universe which has no neutron. There are going to be one or more than one neutrons in all the other elements except hydrogen. So the choice is going to be A choice. The second question is, the lightest gas known to us is fluorine, hydrogen, neon, helium. Again, hydrogen has mass number 1. This is the lightest element that is known to us because the mass number of 1, that is the least mass number we have for any element, right? So hydrogen, this is going to be the lightest element, and because hydrogen in nature on earth, this exists in the form of H2, that is dihydrogen. This is the lightest gas that we have. So the correct choice is going to be B choice. The third question is that hydrogen was named inflammable air by Paracelsus, Robert Boyle, Henry Cavendish, and Antoine Lavoisier. So, Paracelsus was the one who was first one to artificially synthesize hydrogen when he was mixing some metals with strong acids. But he did not understand what gas he had produced while he was doing that reaction. So that just left undiscovered actually, right? So next it was Robert Boyle who studied probably some notes which were left behind by Paracelsus, and while he was studying these notes he learned that he was mixing some metals with some acids. So what he did was, in the year 1660, he repeated that experiment. He prepared hydrogen by the action of dilute H2SO4 on iron powder. Next, it was Henry Cavendish in the year 1766 who prepared hydrogen by the action of dilute HCl with zinc. He studied the properties of the gas that was being released. He found it to be an inflammable gas, and that is why he called it inflammable air. Okay. Also, you can remember over here that he was the one who found out that when hydrogen is going to burn in air, it is going to produce water. Okay, now he did not name this gas, so it was just inflammable here till Henry Cavendish. Then it was Antoine Lavoisier who named the gas hydrogen. Okay, so these are as far as the important people who are related with the discovery of hydrogen. Fine, I hope this is clear. So what is going to be the correct choice? Hydrogen was named inflammable air by Henry Cavendish. The next question is, which of the following statements is not true for hydrogen? So the first choice is that it exists as a diatomic molecule. It is present in our atmosphere in a large amount. It has one electron in the outermost shell. It is the most abundant element in our universe. So as far as the first choice is concerned, hydrogen, this exists as H2. Dihydrogen, which is a diatomic molecule. Diatomic means that it is going to have two atoms in the molecule. So when there are going to be two atoms in the molecule of hydrogen, it is going to be H2. So what we see is that on the Earth's surface, we have hydrogen existing as H2. Right? So this is existing as a diatomic molecule. So this is correct. It is present in our atmosphere in a large amount. Now, this is not correct. Why it is not correct? This is not correct because it is not found in our atmosphere in a large amount. In fact, it is only 0.15% by mass in the Earth's atmosphere. Now, can you tell why is it so? Well, this is because we have just now studied that hydrogen is the lightest gas that is known to us. Right? Now it is so light that the Earth's gravitational pull, this is not so strong to hold hydrogen in its atmosphere. So we do not have hydrogen in a large quantity in our atmosphere. Hydrogen on Earth is going to be present more in the form of a combination with other elements in the form of compounds. For example, you all know in the form of water, right? So in water, in plant tissues, in animal tissues, proteins, carbohydrates, and why not mention the hydrocarbons, the petrochemicals. So in all these forms, hydrogen is present to us. But in our atmosphere, it is not present in a large amount. It is present very less. Okay, the next we have is that it has one electron in the outermost shell. So you all can understand it has one electron. So that is going to be present in the 1s orbital. So this is also going to be correct. And this is the most abundant element in our universe. So 70% of our universe by mass is composed of hydrogen, making hydrogen the most abundant element in our universe. Here one thing more which you can remember is that 90% of the solar atmosphere, that is also made up of hydrogen. So this is going to be the most abundant element of the solar atmosphere also, and here hydrogen is responsible for the sun's light and energy. In the solar atmosphere, four hydrogen nuclei, they are combining together to form a helium nuclei in the nuclear fusion reaction. And here, when the nuclear fusion reaction is occurring, a large amount of energy is being released, which we are receiving from the sun as light and heat. So the correct choice over here, which of the following statements is not true for hydrogen, is going to be B choice. The next we have is, in Greek, hydrogen means water producer, oil producer, smoke producer, milk producer. So hydrogen is derived from two words, Greek words. One is hydra, which means water, and the other is genas, which means generator. So this word hydrogen, this was coined by Antony Lavoisier from these two Greek words, hydra and genas. So he now knew, after the understanding from Henry Cavendish, that hydrogen can be used to prepare water. So that is why he named the gas as hydrogen. Water producer, hydrogenous, right? So I hope this is clear. So the correct choice is going to be A choice. So next we begin with question number 6, and here before I begin, let me tell you that question number 6 to 10, the theory related to that you can have an understanding in lecture number 2 from our course hydrogen. Here what we will be discussing is the position of hydrogen in the periodic table, how hydrogen, this is similar to the alkali metals as well as to the halogens, and what are going to be the things which are going to be different of hydrogen from these two group of elements. So the sixth question, as you can see, this is a question which has been asked in the NCERT exemplar. So here I would not miss telling you that the NCERT exemplar and the NCERT textbook, they are very important for you. Please do read the NCERT textbook, do solve the back exercise questions of the NCERT book, and also attempt all the questions of the NCERT exemplar. For this course hydrogen, we have tried our level best to put in as many as questions possible from the NCERT exemplar also. Okay, but please, for all your courses, I would request you, read the NCERT textbook, solve the back exercise questions, as well as solve the questions from the NCERT exemplar. Fine. Now this question says that hydrogen resembles halogens in many respects, for which several factors are responsible. Of the following factors, which one is the most important in this respect? So the first choice is its tendency to lose an electron to form a cation, its tendency to gain a single electron in its valence shell to attain stable electronic configuration, its low negative electron gain enthalpy value, its small size. So as far as the answer is concerned, this is B choice, as you can see written over here. But let us discuss all of these points. They are going to be important for our understanding. Fine. So the first choice is its tendency to lose an electron to form a cation. In this respect, it is going to be similar to not halogens but similar to the alkali metals. Hydrogen and alkali metals, they have the general electronic configuration NS1, one electron in the outermost shell. So here hydrogen and alkali metals are the ones which can lose that electron to form a cation and attain the nearest noble gas configuration. Okay, the next choice, that it has a tendency to gain an electron in its valence shell to attain stable electronic configuration. This is going to be similar to the halogens. Halogens, they have the general electronic configuration Ns2 Np5. So they gain one electron, they will be attaining the configuration Ns2 Np6, that is of the noble gas. Similarly, hydrogen, it has the electronic configuration 1s1. If it gains one electron, that will be the configuration of helium 1s2, again a noble gas. So here the tendency to gain an electron in the valence shell is going to be similar for hydrogen and halogens. Okay, so this means that the choice B is correct. Now the C choice, it has low negative electron gain enthalpy value. Well, this is also going to be similar to the alkali metals. The halogens, they have high negative electron gain enthalpy value. Now you would be saying that hydrogen, well, this also has a tendency to gain an electron. Halogens, they also have a tendency to gain an electron. Why the value is different? Why hydrogen has a low negative electron gain enthalpy value, whereas halogens, they have high electron gain enthalpy value? The reason is the small size of hydrogen. The incoming electron feels more of a repulsion. Therefore, hydrogen, this has a low negative electron gain enthalpy, whereas the halogens, they have a high electron gain enthalpy value. Okay, but do remember that the value is going to be a negative electron gain enthalpy value for hydrogen as well. The next we have is the small size of hydrogen. So hydrogen, this has a small size. Similar to hydrogen, the halogens in their respective period, they will be having a small size, but well, this is not the property which is making hydrogen being similar more to the halogens. Okay, so the correct choice over here is going to be the C choice. Sorry, the B choice. The next we have is, why does H positive ion always get associated with other atoms or molecules? The choices are: ionization enthalpy of hydrogen resembles that of alkali metals. Its reactivity is similar to halogens. It resembles both alkali metals and halogens. Loss of an electron from hydrogen atoms results in a nucleus of very small size as compared to other atoms or ions. Due to small size, it cannot exist free. So H positive is nothing but one proton, right? So hydrogen has one proton and one electron. When it loses one electron, what is left behind is only H positive, which is one proton, and a proton is very small in size. Okay, so this H positive, this does not have an independent existence. It cannot live independently. It always is associated with other atoms and ions. And for example, if you look at the aqueous solution, what you will be seeing is that H positive will always get associated with water molecules. And when it is getting associated with water molecule, it cannot get associated with only one water molecule. It can get more associated with more than one water molecule also. So the general formula for the aqueous state of H positive will be H positive H2O N. When that N is 1, it is going to be H positive H2O, which if you are going to combine together, you will be getting H3O positive, which we call as the hydronium ion. Okay, but it can exist as H positive H2O twice, thrice, four times, and so on. So it is going to be always associated with some other atom or molecules, and this is because of its small size that it cannot exist free. The other choices, well, obviously they are going to be incorrect over here, but I just wanted to talk about the ionization enthalpy of hydrogen also resembling that of alkali metals. Well, the ionization enthalpy of hydrogen is quite high in comparison to the ionization enthalpy of the alkali metals. Alkali metals have low ionization enthalpy values. They really have a tendency to lose that electron they have so as to attain the nearest noble gas configuration. But as far as hydrogen is concerned, the ionization enthalpy value is high because again the atom of hydrogen is small. So that electron is strongly held by the nucleus of hydrogen atom, and therefore we have to supply a lot of energy to remove that electron. So in this respect, the ionization enthalpy of hydrogen is going to be similar to that of halogens, which also have high ionization enthalpy values. Okay. The reactivity, well, it is going to be similar in some cases to halogens, some cases to alkali metals, and it is going to resemble both alkali metals and halogens. So this is also one thing that is correct as far as halogen is concerned. But as far as this question is concerned, the correct choice is going to be D choice. And this is also a question which has been asked in the NCERT exemplar. So here I would like you to focus on that, just do not choose the correct choice. While you are learning, you should have an understanding of each and every choice that is given to you. Then only your preparation is going to be excellent. The next question is, which of the following statements they are true for hydrogen? And here the choices are: it exists as a diatomic molecule, it has one electron in the outermost shell, it can lose an electron to form a cation which can freely exist, it forms a large number of ionic compounds by losing an electron. And this is also a question from the NCERT exemplar book, and this is a question which has multi-correct options. More than one options are going to be correct. So the first choice is, it is existing as a diatomic molecule. So this is correct. It has one electron in the outermost shell. This is also correct. It can lose an electron to form a cation which can freely exist. So this portion, that it can lose an electron to form H positive ion, which is a cation, is correct. But this cation, that is H positive, we've just now discussed that it does not have an independent existence of its own. So this is going to be an incorrect choice. Fourth, it has forms a large number of ionic compounds by losing an electron. So this is also incorrect. We've just now discussed that the ionization enthalpy of hydrogen is quite high and it is comparable to that of halogens. So hydrogen, like halogens, forms a large number of covalent compounds, whereas it is going to be the alkali metals which are going to have low ionization enthalpy values, and they will be forming predominantly ionic compounds. So the choices which are going to be correct, they are going to be only A and B. The next question is, in which of the following properties hydrogen does not show similarity with alkali metals? And the options are electronic character, reducing nature, electronic configuration, diatomic nature of the molecule. So electronic character, both hydrogen and alkali metals, they can lose again one electron, form unipositive ions, so they are exhibiting a electropositive character, both of them. So this is correct. Reducing nature, both hydrogen and alkali metals, they are strong reducing agents. You can see the reaction examples also, which we have discussed while we were talking about the detailed discussion and comparison of hydrogen to the alkali metals. Okay, so hydrogen and the alkali metals, they are strong reducing agents. This is a correct option. Next, electronic configuration, both having general electronic configuration of NS1. So this is also correct. The fourth choice obviously is going to be the incorrect one. So hydrogen, this is existing in the form of H2. It is similar to halogens in this respect, where they are also forming F2, Cl2, Br2, I2. But the alkali metals, if we look them in the vapor state, because hydrogen is a gas, so we will be comparing the vapor state of alkali metals also. So in the vapor state, alkali metals, they are existing as monoatomic forms. They will not be existing as Li2, Na2, K2, etc. They will be existing as lithium, sodium, potassium atoms. Fine, I hope this is clear. So the atomicity, we can say over here, of alkali metals is going to be 1, whereas the atomicity of hydrogen as well as the halogens is going to be 2. So the correct choice over here is going to be the D choice. Now the 10th question is, in what respect electronic configuration of hydrogen and halogens, they are similar? The first choice is hydrogen and halogens, they have one electron in their outermost shell. So this is a very simple question, so I'll just do it along with, right? So hydrogen and alkali metals, they have one electron in the outermost shell. Hydrogen and halogens, they have one electron less than the nearest noble gas configuration. So this is going to be the correct choice. Then the third choice is hydrogen and halogens, they have noble gas configuration. So this is obviously wrong. And hydrogen and halogens, they can lose one electron to form positive ions. So it is going to be hydrogen and alkali metals that can lose one electron to form positive ions. So the correct choice is going to be B. So now we have finished what all I could discuss over here in relation to hydrogen being similar and dissimilar to both alkali metals and halogens. So if you want to have a quick revision in the lecture 2, as I was just now telling you in our course on hydrogen, well, we have put all these similarities and differences in the form of tables. So you can visit that lecture and quickly write down those tables and revise whenever you want to. Fine. Now moving on to the next question. So question number 11 to 15, they are related to the isotopes of hydrogen, and this is a very important topic, although it is a very easy topic because many questions they are repeatedly coming in the exam competitive examinations from this topic, right? So the isotopes of hydrogen, this question is from JEE Mains 2019 January part, right? So the isotopes of hydrogen, they are tritium and protium only, protium and deuterium only, protium, deuterium and tritium, deuterium and tritium only. So isotopes of hydrogen, they are three in number, that is protium, deuterium and tritium. And if you remember, isotopes are going to be those atoms of the same element which are going to have same atomic number but different mass number. So protium is the one which is having atomic number 1 and mass number 1. Deuterium is having atomic number 1 and mass number 2, and tritium is having atomic number 1 and mass number 3. Fine. So the correct option over here is going to be the C choice. The next question is the total number of isotopes of hydrogen and the number of radioactive isotopes among them respectively are 3 and 1, 3 and 2, 2 and 1, 2 and 0, and this question was asked in JEE Mains January 2019 examination. Also there is a similar question present in the NCERT exemplar book also. So if you've done that, well, this question you cannot miss attempting and getting it correct as well. So the number of isotopes of hydrogen we've just now discussed, there are three in number, protium, deuterium and tritium, and out of these three isotopes it is only one isotope which is radioactive, and that is tritium. So the correct option over here is going to be A choice, three isotopes of hydrogen, and out of them one is radioactive, that is tritium. So the correct option is going to be A choice. Here one more thing which I can tell you, which will not be covered up in the questions which will be following for the isotopes, is that the most common of all the three isotopes of hydrogen, this is protium. Okay, so if we analyze a sample of natural hydrogen, what we will be seeing is that 99.984% of that sample is going to be protium, and 0.0156% of the sample is going to be deuterium. And as far as tritium is concerned, it is just traces, one atom per 10 to the power 18 atoms of protium is what we have in a natural sample of hydrogen. So maximum is going to be protium, then deuterium, and lastly in traces you can say almost negligible is going to be tritium. So this can be asked in the examination, so I was just referring that to you. So the next question is the notation of H12. This stands for protium, heavy hydrogen, deuterium and tritium, and well, you can see the answer also coming along, but I hope you will understand hydrogen with atomic number 1 and mass number 2 is what is deuterium, and deuterium has another name, that is heavy hydrogen. Why it is called heavy hydrogen? Because the commonest form, which is protium, this is having mass number 1, so that will be H11. And because deuterium has a higher mass number than the commonest form, we call this as heavy hydrogen. Hydrogen referring to protium and deuterium heavy hydrogen, right? So the correct options, they are going to be B and C. The next we have is determine the total number of neutrons in the three isotopes of hydrogen. So here the choices are 1, 2, 3, 4, and this was the question which was asked in JEE Mains 2020. The correct option is C choice. There are going to be 3 neutrons, 1 for deuterium, 2 for tritium, and there is no neutron present in protium. So in the whole universe, the only atom which does not have any neutron, now you can say, is going to be protein. So the next question is the isotopes of hydrogen that differ in the rates of chemical reactions due to different bond dissociation enthalpies, different electronic configuration, different chemical properties, different atomic masses. So please do remember that the isotopes, they have similar atomic number, and because they have similar atomic number, they will be having similar chemical properties. It is only that the rate of the chemical reaction is going to differ because of a difference in the bond dissociation enthalpy values. Protium is going to have a lesser bond dissociation enthalpy value than deuterium, and deuterium will be having it less than tritium. Okay, so most reactive out of the three isotopes is going to be protium with a lesser bond dissociation enthalpy value. So the correct choice is going to be A choice. Now moving on to the sixth question, the 16th, 17th and 18th question, they are pertaining to my lecture number 3 from the course hydrogen again, and this is in relation to the different forms of hydrogen. Okay, when I'm talking about the different forms of hydrogen, I'm talking about atomic hydrogen, nascent hydrogen, then we are talking about nuclear isomers, ortho hydrogen, para hydrogen. So this is all what I have discussed in detail in lecture number 3, different forms of hydrogen. Please do visit that lecture, especially those of you who are preparing for JEE Advanced. Please do watch that lecture. That is going to be important and helpful for you. Okay, so here just 3 questions I am putting over here from that lecture. Pure nascent hydrogen, this is obtained from Na and C2H5OH, aluminium and NaOH, zinc and dilute H2SO4, all of this. So all of these are the correct choices. I will not be able to discuss everything once again. So please do watch that lecture. Okay. So the correct choice is going to be D choice. Next we have is which of the following statements are true. So the first is hydrogen. This acts as a reducing agent. Next is that nascent hydrogen, this is stronger reducing agent than H2. Occluded hydrogen is less reactive than ordinary hydrogen, and atomic hydrogen, this is used in welding torch. And the correct options, they are A, B and D. H2 is acting as a reducing agent. We've already discussed it while we were talking in comparison to the alkali metals. Both they are strong reducing agents. We will be discussing more in the chemical properties of dihydrogen, how it acts as a reducing agent. Okay. The next, nascent hydrogen, this is stronger reducing agent than H2. This is also correct. Occluded hydrogen, this is more reactive than ordinary hydrogen. The most reactive of the four, I would say, atomic hydrogen is most reactive. Then we have nascent hydrogen, then occluded hydrogen, and least of them is going to be the molecular hydrogen, that is dihydrogen, as far as the reactivity is concerned. Again, the complete lecture you can watch. I will not be able to discuss everything in the multiple choice questions only. So do watch that lecture. Okay. And atomic hydrogen, this is used in the welding torch because atomic hydrogen means hydrogen atoms. Okay. So these hydrogen atoms, they are very short lived. They have a half-life of just 0.3 seconds, and they quickly combine to form H2, and in that process a large amount of energy is released, which is utilized in the welding of metals. So this is also a correct option. So A, B and D, they are going to be correct options. Now the next question is that select the correct statements. First is ortho and para hydrogen, they differ in their nucleus spins. Ortho and para hydrogen differ in their electronic spins. Para hydrogen, this has lower internal energy than ortho hydrogen. Para hydrogen is more stable at lower temperatures. Now to choose the correct answer over here, well, you have to have an understanding what is ortho and para hydrogen. So here I have tabulated all the differences between ortho and para hydrogen. And well, if you have seen the lecture on different forms of hydrogen, well, it is going to be easy for you to understand, but I'll try my level best to just give you a quick understanding of what is ortho and para hydrogen, what we are meaning over here. So we have a molecule of hydrogen being formed. Okay, so we have a molecule of hydrogen being formed by the two hydrogen atoms. The two hydrogen atoms, they will be having a proton in the nucleus and one electron revolving around the nucleus. And now this electron, you all know that along with revolving around the nucleus, this is also spinning about its own axis. Similarly, there will be one more atom when a hydrogen molecule will be formed, right? So there is also going to be one electron for this also and one proton for this also. So what you know is when this molecule will be formed, both of them, they will be fitting into the only one molecular orbital, and therefore both the electrons, well, they will be having a spin in the opposite direction. So this is what you know from the Pauli's exclusion principle, that when there are going to be two electrons in an orbital, one is going to be having a spin up and the other is going to have a spin down, right? Now, the difference over here is between ortho and para hydrogen is related to the nuclear spin. What nuclear spin means is that along with the electron, the proton which is present, this is also spinning about its own axis. And when these two protons, they are spinning, it can be that the two protons, they are spinning in the same direction, but it is also a possibility that they are spinning in the opposite direction. When the spin is in the same direction, we call this as orthohydrogen, and when it is spinning in the opposite direction, we call it as parahydrogen, right? So just let me rub this out first. So orthohydrogen is the one where the atoms, when they are going to form the hydrogen molecule, they will be having the nuclear spin in the same direction, whereas parahydrogen, the atoms, they have nuclear spin in the opposite direction, right? Now, orthohydrogen, this is more stable than parahydrogen, and therefore parahydrogen is going to be less stable. And when we are talking about the stability, well, it is that the stability of parahydrogen is going to be more at a lower temperature. As we are going to increase the temperature comes up to room temperature, we see that orthohydrogen is going to be more stable. Fine. And then as we are increasing the temperature, the stability of orthohydrogen remains more than that of parahydrogen. Fine. And because the spin is in the same direction for the protons, the nuclear spin, so we will see that orthohydrogen, this has more magnetic moment as compared to parahydrogen. Orthohydrogen, this has less conductivity as compared to parahydrogen. At room temperature, we find the percentage of hydrogen in a natural sample is going to be that hydrogen is going to form 75%, whereas para will be forming 25%. As we are going to lower down the temperature, the percentage of parahydrogen will increase. It can go up till 99 or 100%. In fact, at 0 Kelvin, you will find pure parahydrogen. But as far as the higher temperatures they are going to be concerned, we will be having both ortho as well as para, and it is impossible to isolate orthohydrogen, but at a lower temperature we will be able to isolate parahydrogen. Okay, so if you now choose the choices from here, what will you find is that ortho and parahydrogen, they differ in the nuclear spins, so this is going to be correct. Ortho and parahydrogen, they differ in their electronic spins. No, it is not going to be correct. For both of them, the electrons, they are going to be spinning oppositely, right? One is going to be spinning in the clockwise direction, the other one will be spinning in the anti-clockwise direction. Parahydrogen, this has lower internal energy than orthohydrogen. Please do remember this as well. And parahydrogen, this is more stable at lower temperature, and as we will have room temperature and higher temperature, orthohydrogen will become more stable, right? So the correct choices, they are going to be A, C and D choice. B choice is going to be incorrect. So now on your screen you have question number 19 and 20, and as you will be able to understand when you're going to read these questions are going to be related to the preparation of hydrogen. So let us first of all read these questions and then I will tell you what we are going to do about it. Well, which of the following combinations will produce hydrogen? Iron and concentrated HNO3, copper and concentrated HNO3, zinc and NaOH aqueous, gold metal and NaCN aqueous in presence of air. And this is the question which was asked in JEE Advanced 2017. The next question is that the metal that gives hydrogen gas upon treatment with both acid as well as base is iron, magnesium, zinc and mercury, and this was asked in the JEE Mains January 2019 examination. Well, when we are having reactions, I will not be able to just orally speak those reactions, so I will have you to give you in writing some of the things over here. But again, that will not be complete discussion. You will have to just go back to the lecture number 5 from the detailed course on hydrogen to have a look at all the reactions, right? So when we are preparing hydrogen, we can do it in the following ways. First is by the action of water on metals. So when water is going to react with metals, it is going to produce the corresponding metal hydroxide or oxide, and hydrogen is going to be evolved. Okay, and what you have to remember here is the activity series that you have learned in your junior classes in relation to the metals. All the metals which are going to be more active than hydrogen, they will be able to evolve hydrogen from water. Okay, I will just give you the activity series on the next slide and I will just discuss a bit more about this point. The next we have is by the action of dilute acids on metals. So again, metals, they will be reacting with dilute acids to evolve hydrogen, and all these metals, they are going to be above hydrogen in the activity series. Then we have the action of water on metal hydrides. So metal hydrides, when they will be reacting with water, so metal hydrides, for example, lithium hydride, uh, sodium hydride and so on, when they are going to react with water, you will be getting again hydrogen. Next is by the action of alkalis on amphoteric elements. So what are amphoteric elements? These are those elements which can react both with acids as well as bases. So when they are going to react with either dilute acids or they will be reacting with alkalis, again hydrogen will be evolved. Next we have the laboratory preparation of hydrogen, which is essentially the reaction of metals with dilute acids or with alkalis. So it is going to be just a detailed discussion for the laboratory preparation when we react zinc with dilute H2SO4 that we prepare in the laboratory hydrogen. Next we have is the industrial preparation. So here some important reactions are going to be the Bosch process, where we will be producing hydrogen from coal gasification, then from hydrocarbons. This is going to be very important reaction as far as your examination is concerned. And then there is the electrolysis of water that we have to learn over here. So all the reactions you should be learning under these headings, they should be very clear to you, and then you will be able to do your questions very well. A few of the things I will be discussing over here in this crash course. Now in question number 19, if you remember the choices that how we are going to prepare hydrogen, and the choices were there were two metals and concentrated HNO3. The third choice was with zinc and NaOH. Okay, so here we are discussing the action of dilute mineral acids on metals and the action of alkalis on the amphoteric elements. Okay, so the first we have the action of dilute mineral acids on metals, and as I told you, all the elements which are going to be more reactive than hydrogen, they will be reacting with dilute acids to liberate hydrogen. For example, you have zinc reacting with dilute H2SO4 to produce zinc sulfate and hydrogen, and this is the reaction which we use for the lab preparation of hydrogen. Okay, magnesium plus HCl, again this was generally dilute that we take, but although the reaction this can take place with concentrated HCl also, and magnesium chloride and hydrogen is produced. So these reactions, they are used for the laboratory preparation of hydrogen. Reaction of metals with dilute acids. Next we have is by the action of alkalis on the amphoteric elements. So amphoteric elements, for example, we have zinc, aluminium, lead, tin, antimony, etc. They will be reacting with alkalis to produce hydrogen. For example, zinc, you have seen the reaction with dilute acids. So zinc is an amphoteric element. This can react with an alkali also. So zinc plus NaOH, this will be forming sodium zincate plus hydrogen. Aluminium on reaction with NaOH aqueous solution, this will be forming sodium meta-aluminate and hydrogen. Again, these reactions are also used for the laboratory preparation of hydrogen. Now, before we just wind it up with this discussion over here, well, I will just tell you with the activity series only how we can evolve hydrogen by the action of metals on water, right? So I just now told you that all the metals which are going to be above hydrogen in the activity series, they can evolve hydrogen from water. So what we see is potassium, sodium, calcium, which are highly reactive, top of the activity series. They can react with cold water. Okay, they will be producing the corresponding hydroxide. For example, sodium plus water is going to be NaOH plus hydrogen. Okay, so all these, they will be producing the hydroxide along with hydrogen. Then we have a little less reactive elements like we have magnesium, aluminium. So these elements, they will be reacting with hot water, that is the temperature of 25 to 90 degrees Celsius, and they will be forming the corresponding oxides and hydrogen will be evolved. From iron downwards, well, the reaction is going to take place only with steam, that is temperature above 100 degrees Celsius. Well, lead is also above hydrogen, so this will react slightly with steam, very low reactivity, and initially the reaction, although it is going to be very slow, it is going to form lead oxide and hydrogen. But once a layer of lead oxide is formed on the surface of the metal, well, this breaks up the contact of the uh, metal with water, and therefore the reaction, this cannot proceed further. So generally what we say is that lead does not react with water. Okay, that's due to the formation of an lead oxide layer on the surface of the metal. So these are the reactions as far as action of dilute mineral acids on metals, amphoteric elements and water is concerned. So this is how we are getting hydrogen. So there are certain points now as far as the lab preparation is concerned, or you can say when we are talking about the reaction of dilute acids with the metals, you have to remember these points. So we do use dilute H2SO4, we use dilute, or we can use concentrated HCl also in the experiment. So zinc plus HCl, I told you in the lab preparation we are doing zinc plus dilute H2SO4 to produce zinc sulfate and hydrogen. So when there is going to be a reaction with HCl, it is going to produce zinc chloride and hydrogen. Concentrated or dilute HNO3, this cannot be used because of the reduction to the oxides of nitrogen. So you can see when it is going to be the reaction of zinc with HNO3, it is going to produce zinc nitrate and nascent hydrogen. This nascent hydrogen on reaction further with acid, this is going to form NO2 plus water when it is going to be concentrated HNO3, and when it is going to be dilute HNO3, it is going to be the formation of NO plus water. So we do not get hydrogen over here when the reaction is of the metal and HNO3, either dilute or concentrated. So the question number 19, we'll just now be seeing that in that there was a reaction of metal with concentrated HNO3. So the metals, they are not going to react with concentrated or dilute HNO3 for the production of hydrogen, barring two exceptions, that is magnesium and manganese. They do react with dilute HNO3 to produce hydrogen. Okay, for example, if I give you the reaction of magnesium plus HNO3, this is going to form magnesium nitrate plus hydrogen. Concentrated H2SO4. So this is also not used for hydrogen evolving, again because H2SO4 this gets reduced to sulfur dioxide. The reaction, again, this is in front of you. Okay, so we will be using dilute H2SO4. We use dilute HCl. We can use concentrated HCl, but we never use concentrated or dilute HNO3 for the reaction. So now with all this discussion, let us go back to the questions that you saw, question number 19 and 20, and let us see now can we solve them. So question number 19 was, which of the following combinations will produce hydrogen, iron and concentrated HNO3, copper and concentrated HNO3. So now this should be clear to you that there is going to be no metal which is going to react with concentrated HNO3 to evolve hydrogen, and with dilute HNO3 it is going to be only magnesium and manganese that will be reacting to evolve hydrogen, right? The next is zinc, metal and NaOH. So this is a amphoteric element combining with NaOH. So the reaction is going to evolve hydrogen. Sodium zincate will be produced. Okay, so this choice is going to be the correct choice. Next, it is we have gold reacting with aqueous sodium cyanide in presence of air. And will this produce hydrogen? Well, this is something that you've not studied in the course on hydrogen, but this is something that you studied as a method for leaching for the gold extraction in class 12th when we study the metallurgical processes. So the reaction I'm just giving you over here, in case you do not remember it, please do go back to class 12th course on metallurgy, and there you will be finding this reaction. So gold on reaction with sodium cyanide, water and oxygen, this is going to form sodium dicyanoaurate, and this process is called as MacArthur Forrest process or the cyanide process, which is used as a metallurgical technique for the extraction of gold from low grade gold ore. Okay, the next so the choice over here that is going to be correct, that is going to be C choice. And the next question was, the metal that gives hydrogen gas upon treatment with both acid as well as base is iron, magnesium, zinc and mercury. So I hope now you know all the amphoteric elements are the ones which are going to react both with acid as well as base, and from these elements the amphoteric element that we have is zinc. So the correct choice is going to be C choice. So the next question for the preparation of hydrogen is that very pure hydrogen, 99.9%, this can be made by which of the following processes? Reaction of methane with steam, mixing natural hydrocarbons of high molecular weight, electrolysis of barium hydroxide solution, reaction of salts like hydrides with water. And this was asked for the All India Engineering Entrance Examination 2012. And this is something we had for the engineering students before JEE Mains was introduced. So here let us start with the D choice, which we have already discussed, that when the hydrides, they will be reacting with water, they will be producing the corresponding hydroxide and hydrogen will be evolved. So this is a reaction we used for the preparation of hydrogen, but well, this is not going to give us very pure hydrogen. The next we have is the electrolysis of barium hydroxide solution. So it is from here we will be getting very pure hydrogen, which is going to be 99.9% more or even more than that. That is so much pure. And here what more you have to remember is regarding the electrolysis of water. We will be getting on electrolysis hydrogen at the cathode and oxygen at the anode. But when we are doing an electrolysis of water, we do not do the electrolysis of pure water because pure water is not a good conductor of electricity. So we either add a dilute slight acid to it, or we add a slight alkali to it to make it conducting. So when we are going to add, for example, when we are adding sodium hydroxide or potassium hydroxide to make it alkaline, you will be seeing that there are going to be some interferences by carbon dioxide which is going to be present in water, right? So there is slight amount of carbon dioxide which is dissolved in water. So that can interfere with the electrolysis process and we will not be getting very pure hydrogen. But then if we use, rather than using potassium hydroxide or sodium hydroxide, we use barium hydroxide. So barium hydroxide, this reacts with carbon dioxide and it is going to produce barium carbonate. And when barium carbonate is produced, well, this is a white precipitate, so it is going to settle down, and hence carbon dioxide will not be interfering with the electrolysis. Okay, so that is how we make very pure hydrogen. But the choices can be either electrolysis of water or electrolysis of barium hydroxide solution, which is going to give us very pure hydrogen. Okay, so this is going to be C choice. Mixing natural hydrocarbons of high molecular weight. Well, we are mixing them, so there's going to be no reaction occurring over here. And the reaction of methane with steam is something again very important, which is one of the most frequently used reaction for the preparation of hydrogen on the industrial level, right? The process, this is called as MOSH process. In this process, when methane, this is going to react with steam at a very high temperature, what we will be getting is a mixture of carbon monoxide and hydrogen. You will just now get the reactions on the next question. Okay, so just listen to, then we will be revising with the reactions again. So carbon monoxide and hydrogen mixture we will get when methane will be reacting with water in the form of steam at a very high temperature. Carbon monoxide and hydrogen mixture is called as water gas. Okay, and this water gas, when we are going to react with more of steam, we will be getting carbon dioxide and hydrogen. Okay, and then we pass that carbon dioxide hydrogen mixture through water under a high pressure. Carbon dioxide dissolves in water and we will be getting hydrogen. So this is one way which we can make hydrogen in the industry. The process is called as Bosch process. Rather than steam, with methane, we can also use red hot coke, and that process is called as coal gasification. Okay, so this is as far as A choice is concerned. We are producing hydrogen and we are producing it on the industrial level, the maximum percentage coming by this reaction, but not getting pure, very pure hydrogen over here. So the correct choice is going to be C choice. The next we have is the synonym for water gas when used in the production of methanol. So I just now told you that methane and steam, or coke and steam, they are going to produce a mixture of carbon monoxide and hydrogen, which we call as water gas. Now there is a synonym for water gas, and that synonym is syngas. The correct answer over here is going to be A choice, syngas. And why we call it as syngas is because the full form of syngas is synthesis gas. It is used for the synthesis of methanol and many other organic compounds. That is why we call water gas as syngas. Okay, and this was the question which was asked for the JEE Mains January 2019. So you will be seeing the reactions on the next slide. So now coming up to the last question for the preparation of hydrogen, and this is the question which I was referring to as the industrial preparation of hydrogen, that is the Bosch process. Okay, so here this question says which of the following reaction is an example of use of water gas in the synthesis of other compounds. The choices: methane reaction with water to produce carbon monoxide and hydrogen, carbon monoxide, hydrogen plus water forming carbon dioxide and hydrogen, an alkane CnH2n plus 2 in presence of a catalyst forming methanol, and carbon monoxide and hydrogen again in the presence of a catalyst forming methanol. And this is a question which is asked in the NCERT exemplar now. So first reaction is CH4 reacting with water. This is a gas, so this is reacting with steam over here. This is a high temperature, right? So methane reacting with steam at a high temperature producing carbon monoxide and hydrogen mixture. This is called as water gas. This is the reaction I was referring to in the previous question. Fine. So this is the reaction where we have a hydrocarbon, I'm repeating it again, reacting with steam at a high temperature of 1270 Kelvin to produce water gas. Fine. So this water gas, now this consists of hydrogen. Okay. Now what we do next is that we pass this water gas again through steam. The second reaction that we have, again at a temperature of 673 Kelvin and a catalyst presence. So what is going to form is carbon dioxide and hydrogen. This reaction over here, this is called as water gas shift reaction. Okay, so please do remember this. That is why I was just waiting for this question so that I can give you the reactions as well. So here now, this is water shift reaction, and here we have carbon dioxide being formed and hydrogen being formed. So we have to remove now carbon dioxide from this to get hydrogen. So what we generally do is we pass this through water at a very high pressure. So what happens is carbon dioxide, this is soluble in water, so this will be dissolving in water, and what we will be getting is only hydrogen. It can also be absorbed by sodium arsenide solution. So these are the ways how we will be getting hydrogen as far as the industrial preparation of hydrogen is concerned. Instead of methane or any other hydrocarbons, we can also use red hot coke for this reaction. When we use red hot coke, we call this as coal gasification. Okay, these are certain things that you have to remember. Now, as I was telling you in the last slide question, that we can use water gas for the synthesis of many other organic compounds, chiefly being methanol, because it will be from methanol that we will be synthesizing many other organic compounds, right? So for that, the reaction we have is that carbon monoxide and hydrogen, which is what, which is water gas. So this, in presence of a catalyst, this is forming methanol. So this reaction is referred to as the reaction which we use for the synthesis of methanol. So this is what we have been asked in the NCERT example. This is a very important question, how methanol is produced from water gas. So the correct answer over here is going to be D choice. Now the next question, which of the following metal absorbs hydrogen? So with this, for the next 5 questions, we are going to discuss the properties and uses of hydrogen. And as far as my detailed course on hydrogen is concerned, this is going to be lecture number 6. So you can watch that lecture in case you have any doubts. So which of the following metals absorbs hydrogen? The choices, they are zinc, palladium, potassium, and aluminium. So here, what you have to remember related to adsorption is, I hope I do not have to explain what is adsorption. You have already discussed this in detail while you studied the chapter on surface chemistry. So as far as hydrogen is concerned and adsorption is concerned, there are a few important points which you should remember. So that is going to be that hydrogen molecules, well, they break into atoms, or their valence bonds, they weaken to get adsorbed on the surface of finely divided metals like palladium, platinum, nickel, cobalt, etc., making these more active to react. So as far as the question is concerned, you all will be able to see that it is going to be palladium, which is the metal which is going to adsorb hydrogen, and generally hydrogen, this gets adsorbed on the surface of the transition metals. Now, the next what we have is that palladium, please do remember this can absorb 800 times its own volume of hydrogen. Adsorption of gas by a metal, this is called as occlusion, and the adsorbed hydrogen, this is called as occluded hydrogen. And the reactivity of occluded hydrogen, this is greater than the reactivity of molecular hydrogen. But the reactivity of occluded hydrogen, this is going to be less than atomic and nascent hydrogen. So if somebody asks you the order for the reactivity of the four types of hydrogen, atomic hydrogen is going to be the most reactive, then nascent hydrogen, then occluded, and last of all is going to be molecular hydrogen. And why is that also? Let me discuss that. Well, molecular hydrogen, this has a high bond dissociation enthalpy value. In fact, for all the elements with single bonds, the bond dissociation enthalpy for hydrogen, this is the highest. So a lot of energy is required to break that bond, and hence molecular hydrogen, this is in fact chemically unreactive and inert at room temperature. So all the reactions of molecular hydrogen we will be seeing when we have temperature which is going to be high or along with the use of a catalyst. The next, the occlusion, well, this is going to increase with increase in surface area of the metal and vice versa. So as far as this question was concerned, well, the answer was B choice. The next question is hydrogen will not reduce which of the following oxides: aluminium oxide, calcium oxide, iron oxide, none of these, and this was asked for the AFMC examination 2009. So here what you have to remember is that hydrogen will be able to reduce only the oxides of those metals which are below iron in the reactivity series. Right. For example, we have copper oxide being reduced to copper, lead oxide being reduced to lead, and so on. So aluminium oxide, calcium oxide, and iron oxides, these will not be reduced to the corresponding metal by hydrogen, and the correct choice is going to be D choice. The next is which of the following statements is incorrect. This question was asked for the NEET examination 2016, and this is also the same question which is present in the NCERT exemplar book. So uh, please understand the importance of the book. Okay, so we have the first choice: hydrogen never acts as a cation in ionic salts. Then hydronium ion H3O positive exists freely in solution. Dihydrogen does not act as a reducing agent. Hydrogen has three isotopes, out of which tritium, this is the most common. So most of the things we've already discussed. Hydrogen, this is not going to act as a cation in the ionic salts because H positive does not have a free existence. Hydronium ion, this exists freely in solution. So this is also correct. And then dihydrogen does not act as a reducing agent. Well, this does, and you've already seen the reactions also that it is a reducing agent, and hydrogen has three isotopes, but out of them protium is the one which is the most common. So the correct options, they are C and D. So the next question is, among the following reactions of hydrogen with halogens, the one that requires a catalyst is hydrogen and iodine reaction, hydrogen and chlorine reaction, hydrogen with bromine, hydrogen with fluorine. And this question was asked for the JEE Mains January 2019 examination. So all the reacting conditions, well, they are very important for you people to remember. Hydrogen reacts with fluorine in dark, with chlorine in diffuse sunlight, with bromine when we are going to heat the mixture, and with iodine when we have a catalyst, and 675 Kelvin of temperature. So all these conditions you should remember very well. That is one thing. And other thing that you should remember is from here we get the reactivity order for the various halogens. So the reactivity order is going to be that fluorine is most reactive, then chlorine, then bromine, and then iodine. So the correct choice, that which halogen requires a catalyst, is going to be A choice. Hydrogen and iodine reaction, this requires the presence of a catalyst. Now the next question, this is a matching type of question, and this is something that is asked in the JEE advanced examination. So we are trying here to give you a mixed bag of questions: single correct answer questions, multiple correct answer questions, assertion reason type of questions, matching type of questions. So what are all asked in the various examination. Now as far as the choices now they are concerned, let us discuss them one by one so you'll automatically get the proper matching. So we have lithium lithium aluminium hydride, which is used as a reducing agent. It is used very frequently in organic chemistry, and I hope I do not have to give you those reactions, because here I'm talking more about hydrogen and its compounds. So this is what I would like to discuss over here, is the making of lithium aluminium hydride. Okay, so what we have is that lithium hydride, this is very unreactive at moderate temperature with oxygen or chlorine, and hence it is used for the synthesis of other useful hydrides, which are very good reducing agents. So lithium hydride on reaction with aluminium chloride, it forms lithium aluminium hydride, and when it reacts with diborane, that is B2H6, it is going to form lithium borohydride. And when we are talking about lithium hydride being unreactive, you should also remember what about the other hydrides. So the other hydrides down the group, they are going to be reactive. For example, if I talk about the next metal, that will be sodium. So sodium hydride, this on reaction with oxygen, you can write it down somewhere, this is going to be the formation of NaOH. And when it will be reacting with chlorine, it is going to form NaCl plus HCl. When it is going to react with water, it is going to form NaOH and hydrogen will be evolved. So, but that reaction will be given by lithium hydride as well. So lithium hydride is also going to form the corresponding hydroxide, and hydrogen will be evolved, which is one of the reactions for the preparation of hydrogen. Right, so the reaction of hydrides with water, they produce the corresponding hydroxide and hydrogen is evolved. Right. So we have lithium aluminium hydride being used as a reducing agent now. So liquid hydrogen, this is the next use of hydrogen we have. It is used as a rocket fuel along with liquid oxygen. Next we have is atomic hydrogen. So atomic hydrogen, this recombines on metal surface to generate high temperature. This is something that we have done previously also, that atomic hydrogen, this has a very short half-life, just of 0.3 second. So it rapidly combines to form molecular hydrogen, and in the process a large amount of energy is released, and that is the energy that is used for the welding of metals, for the cutting of metals. So atomic hydrogen, this is recombining on metal surface to generate high temperature, and this high temperature is going to be helpful in either cutting the metal or welding the metals. The next we have is H2. This can be used in the hydroformylation of olefins. Okay, so hydroformylation, formyl is CHO group and hydro is going to be hydrogen. So let us see the reaction. So here we have an alkene on reaction with carbon monoxide and hydrogen, and this hydrogen and carbon monoxide mixture is called as what? This is called as water gas, right? So water gas on reaction with we have an alkene. So what is going to be there is we are going to see the adding up of the CHO group on one and on the hydrogen on the other end of the double bond. So you can see over here, this is going to be our CH2. We have added a carbon and we have added a CHO group on the other side to the other carbon. So this is hydroformylation of olefins, and this on further reduction with hydrogen is going to produce the corresponding alcohol. So first we have hydroformylation of olefins into aldehyde, and then on further reduction with hydrogen we will be getting an alcohol. Here when we are reducing this with H2, just one more reaction, let us talk about that also. So when an alkene or an alkyne, this is going to be reacting with hydrogen, it is going to be again an addition reaction, and the unsaturated compound is get converting into the saturated compound. The alkynes and the alkenes, they will get converted into the corresponding alkane, and this is again which we use as one of the uses of hydrogen into the hydrogenation of the oils, converting of vegetable oils into ghees. So the choices now, I hope they are all clear to you. 1 is going to be C, 2 will be D, 3 will be A, and 4 will be B. So now the next question onwards, for the 10 questions, not 5 questions, but 10 questions, we will be discussing hydrides and hydrogen as a fuel. And why 10 questions? It is because in the NCERT exemplar book, there are many questions from hydrides. And if you look at the previous competitive examination questions, 4 out of the various sets which came for the JEE Mains January examination, well, 4 questions, just imagine, they were coming from the topic only of hydrides. So this topic is very important and I'm not going to leave anything over here. So the first question is that sodium hydride, this is an example of electron rich hydride, metallic hydride, saline hydride, molecular hydride. So what you have to remember is what are ionic hydrides. Ionic hydrides, they are also called as saline hydrides and salt-like hydrides. So ionic hydrides, these are the compounds of hydrogen with S block elements except beryllium and magnesium, which are going to be covalent hydrides. Alright, so all the S block elements except beryllium and magnesium, they are going to make ionic hydrides, and because they have a structure like the rock salt, so they are also called as saline and salt-like hydrides. So the properties are also going to be like that of ionic compounds. Okay. The next we have is covalent or molecular hydrides. So these are going to be the compounds of hydrogen with most of the p block elements, and these are going to exist as molecules, and being covalent in nature, they are called as covalent hydrides or they are called as molecular hydrides. The next we have is metallic, non-stoichiometric or interstitial hydrides. So metallic hydrides are going to be the compounds of hydrogen with the D and the F block elements. They are going to be metallic in appearance, therefore they are called as metallic hydrides. They are called as non-stoichiometric hydrides because here the ratio of the elements, these are not whole numbers and also not definite ones also. So you can see in the example lanthanum hydrogen 2.875. So this 1 is to 2.875 the ratio. It is not a whole number ratio. Therefore these are non-stoichiometric hydrides, and these in these hydrides, hydrogen just fits into the metal lattice of various elements. So what we call them as interstitial hydrides. Okay. So now the question is that sodium hydride, this is an example of which hydride? So sodium is an alkali metal, S block element. So the correct option is going to be C choice. That is, it is a saline hydride, right? So the correct option is C option. The next we have is, there are three questions. I'll just quickly do them. The hydride that is not electron deficient is. Now, as far as the covalent hydrides they are concerned, they are going to be three types: electron deficient, electron precise, and electron rich. All the group 13 element hydrides, they are called as electron deficient hydrides because for them the central atoms octet will not be complete. For example, if you look at boron hydride, gallium hydride, aluminium hydride. Okay, all these three, they are group 13 elements, and if I just look at aluminium, aluminium has 3 electrons in the valence shell, right? So 3 electrons bonding with 3 hydrogen atoms, so it is going to be 6 electrons. It is not going to be a complete octet for aluminium as well as gallium as well as boron. So these are all going to be electron deficient hydrides. Next we look at this option. This is silicon hydride. So silicon, well, this has 4 electrons in the valence shell. All the group 14 elements, they will be having 4 electrons in the valence shell. They will be forming 4 bonds. So their central atom octet is complete, and such hydrides, they are called as electron precise hydrides. And what is left behind is electron rich hydrides. For example, we have ammonia, we have water, we have HF. So all group 15, 16 and 17 element hydrides, they are called as electron rich hydrides because in them the central atom will be having lone pair of electrons. Okay, so this is what you have to remember over here. So the hydride which is not going to be electron deficient, this is going to be A choice. This was asked in the JEE Mains January 2019 examination. Which of the following groups of the periodic table do not form hydrides? So the choices, they are 7, 8, 9 group, 13 group, group 15, 16, 17 and group 14. So group 7, 8, 9, these are the D block elements. These are the groups where no hydrides will be formed, and these groups, we also call them as the hydride gap. Along with group 7, 8 and 9, also group 18, that is the noble gases, they also do not form any hydrides. But this is what we refer to as the hydride gap. Group 1 to group 6, we are having hydrides. Then from 10 to 17, we will be having hydrides. Okay, group 13, they are going to form electron deficient hydrides. 15, 16, 17 electron rich hydrides, and group 14 electron precise hydrides. So group 7, 8, 9, please do remember as the hydride gap. No hydrides being formed, and therefore the choice is going to be A choice, NCERT exemplar question. Only element of which group forms a hydride? So this is choice is group 6, 7, 8 and 9. So group 6, only one element forms a hydride, and that element is chromium. Apart from chromium, no other element of group 6 is going to form a hydride. So the correct option is going to be A, and again this is an NCERT exemplar question. Now the next question we have is the correct statements among these are: saline hydrides produce H2 gas when reacted with water. Reaction of lithium aluminium hydride with BF3, this leads to B2H6 formation. PH3CH4, they are electron rich and electron precise hydrides respectively. HF and CH4, they are molecular hydrides. The choices A and D only, ABC, all ACD, and this was asked for JEE Mains January 2019. So the first we have is that saline hydride, when they will be reacting with water, they will be producing hydrogen gas. So this is correct. And here this reaction is a highly exothermic reaction in which NaOH and hydrogen is formed. Okay, so this is going to be a correct choice. All the saline hydrides, when they will be reacting with with water, they will be producing hydrogen. Okay, so this is one way of preparation of hydrogen, please do remember. Now the next is reaction of lithium aluminium hydride with BF3, this leads to P2H6 formation. So this is not a reaction which was given in the chapter on hydrogen, but this is given in group 13 element reactions when we discuss the formation of diborane, that is B2H6. So this reaction is lithium aluminium hydride, then this reacts with BF3, this leads to the formation of B2H6 lithium fluoride and AlF3 aluminium fluoride, right? So this reaction is also correct over here. So this choice is going to be correct choice. The next we have is PH3. This is electron rich hydride. So phosphorus, this is a group 15 element. It has one lone pair of electrons. So this is going to be electron rich hydride. CH4 carbon group 14 element. So this is going to be electron precise hydride. HF and CH4, they are molecular hydrides. So all the p block elements, they are making what hydrides? They are making molecular hydrides. So choice is going to be C choice. All the four options, they are correct. So C choice. Now the next question, which of the following is correct? Elements of group 15, they form electron deficient hydrides. So let us do along with now. We've done a lot of discussion over here. So elements of group 15, they form electron rich hydrides, not electron deficient hydrides. They have a lone pair of electrons. All elements of group 14, they form electron precise hydrides. So this is going to be correct. Electron precise hydrides, please, I hope you all know that they will be forming 4 bonds. So it is going to be a tetrahedral geometry. Electron rich hydrides, they can act as Lewis aces. So now what are Lewis aces? Lewis aces, they can accept electrons, whereas Lewis bases, they can donate electrons. So electron rich hydrides, they have lone pair of electrons, so they are the ones which will be donating electrons, hence they will be acting as Lewis bases and not Lewis aces. Electron deficient compounds, that is group 13 hydrides, they will be acting as Lewis aces. So this question was asked again in the NCERT exemplar book, and the correct options, they are going to be B and C option. The next we have is which of the following statement is correct? Metal hydrides, they are hydrogen deficient. So this is going to be correct. You have already seen the examples. The hydrogen, that was not a whole number ratio. So you say that metallic hydrides, they are hydrogen deficient. Metal hydrides, they conduct heat and electricity. So we've already discussed that the metallic hydrides, they have metallic properties just like the corresponding metal, right? So they are metallic in nature. That is why we call them as metallic hydrides. The only difference is going to be they will be having their properties slightly less than the corresponding metal. So what this means is that if a metal conducts heat and electricity, the metal hydride will be also conducting heat and electricity, but not that well as the metal itself. The next we have Ionic hydrides, they do not conduct electricity in the solid state, so they are not going to ionize, so hence they will not be conducting electricity in the solid state. This is also going to be correct. Ionic hydrides, they are very good conductors of electricity in the solid state, so therefore obviously this is going to be incorrect. It is going to be either in the aqueous solution or in the molten state that these ionic hydrides, they will be able to conduct electricity, and when an electrolysis is going to be done, hydrogen will be obtained at the anode. Okay, and this is also when we see the electrolysis, what we come to know is that H negative is existing. So the electrolysis of hydrogen and the release of the electrolysis of the ionic hydrides and the release of hydrogen at the anode, this shows that we have the existence of H negative with us. So the correct option over here, they are going to be A, B and C choices, and ionic hydrides, they are going to be very good conductors of electricity only in the aqueous state or in the molten state. The next question is that metal hydrides, they are ionic, covalent or molecular in nature among lithium hydride, sodium hydride, potassium, rubidium, cesium hydride. The correct order of increasing ionic character is, and the four choices they are given to you, and this is a question which is asked in the NCERT exemplar quiz. So now how are we going to choose that which of these compounds is going to have the maximum ionic character? So we see that for all the choices, the anion is the same. It is only a difference in the cation. So how easily an atom can form the corresponding cation is going to determine its ionic character. More easily it can form the cation, more is going to be the ionic character. And if you look at these are all group 1 elements, and in a group, as we move down the group, the size of the atom increases and the ionization enthalpy value decreases. The atom can lose an electron easily to form the corresponding cation. So this means that in group 1, lithium is going to be having the maximum ionization enthalpy value, and cesium will be having the least ionization enthalpy value, and therefore the maximum ionic character is going to be for cesium hydride, and it is going to be increasing from lithium to cesium, the ionic character. Right, so lithium, sodium, then potassium, then rubidium and cesium hydride having the maximum ionic character. Similarly, we can talk this on the basis of electronegativity value also. The electronegativity value also decreases down the group. Fine. So the correct choice is going to be B choice over here. Down the group, the atom size is increasing. Therefore, the atom can lose an electron easily to form the corresponding cation, and hence for the compound, the ionic character will be more. Okay. So the correct choice is B choice. The next we have is which of the following is correct? The assertion and reason type of question, which is generally asked in the IIT entrance examination. So here the question is also asked in the NCERT exemplar, and the assertion is that some metals like platinum and palladium, they can be used as storage media for hydrogen. The reason is that platinum and palladium, they can absorb large volumes of hydrogen. So either A and R both are correct, and R is the correct explanation of A. A is correct, R is not. Both are correct, but R is not the correct explanation of A, or both A and R are false. So the assertion that some metals like platinum and palladium, they can be used as a storage media for hydrogen, this is correct. We've studied it, and in one of the previous questions also we have seen that why it is being done. It is because platinum and palladium, they can absorb large volumes of hydrogen, and therefore they can be used to store hydrogen and help in its transport as well. Right, so the correct answer is going to be over here, A choice. So next we have is the 38th question, and this is in fact the last question as far as this lecture is concerned. The remaining topics related to water, heavy water and hydrogen peroxide is something that we will be doing in part 2 of this course. So the question is that regarding hydrogen as a fuel, which is correct? It produces less pollutants than petrol. A cylinder of compressed dihydrogen weighs 30 times more than a petrol tank, producing the same amount of energy. Dihydrogen is stored in tanks of metal alloys like sodium nickel alloy. On combustion, values of energy released per gram of liquid dihydrogen and LPG are 50 and 142 kilojoule respectively, and the choices are that B and D are correct, A and D correct, B, C, D correct, A, B, C correct. And this is question which was asked in JEE Mains January 2019. So this is related to the use of hydrogen as a fuel. There are going to be there are going to be certain advantages which make hydrogen as a potential energy source for the future generations. And the advantages it has is that first of all, it is going to cause minimal pollution, we can say, as compared to the conventional sources of energy. And why we are saying minimal pollution is because if we just talk about the combustion of hydrogen, it is going to be H2 plus O2 forming water, so there is going to be no pollution. But when we have hydrogen in a cylinder, there is going to be nitrogen present along with hydrogen in the cylinder. And when there is going to be a combustion of that, hydrogen plus oxygen is obviously going to produce water, but nitrogen is also going to combine with oxygen, and hence oxides of nitrogen are going to be produced, and they are pollutant. So we say that there is going to be minimal pollution as far as using hydrogen as a fuel is concerned. And when I'm telling you this, there is one solution to this problem as well. Let me tell you that also. And that is that in the cylinder which is going to contain hydrogen and nitrogen as an impurity, we can add a small amount of water, and that is going to lower down the temperature, and hence the reaction between N2 and O2 will not occur. Right, so the pollution will not be there. So hydrogen as a fuel, this is going to cause minimal pollution. There is going to be no carbon dioxide release, so there is no greenhouse effect, and hence the global warming, which is a big concern for us these days, well, that would not be happening. So we have hydrogen as a potential source of energy. Another important thing which makes hydrogen as a fuel is that if we look at now the D choice, on combustion, the values of energy that is released per gram of liquid dihydrogen, in fact, this is 142, it is not 50, this is 142 kilojoule per gram, whereas for LPG, this is 50 kilojoule per gram. Right, so what we see is that the energy released from liquid dihydrogen and even gaseous hydrogen, that is going to be 143 kilojoule per mole. So that is much higher than the conventional sources of energy. So this makes hydrogen a potential source of energy. But the problem is that there are certain disadvantages or limitations of using hydrogen as a fuel, and they are one thing that I told you, that impurity, that is nitrogen going to be present and oxides of nitrogen being there. But more important than that is that if we look at the weight hydrogen occupies in comparison to a petrol tank. So a cylinder of compressed dihydrogen, this is a correct statement, that is weighs 30 times more than a petrol tank, which is going to give us the same amount of energy. So this means that transportation and storage of hydrogen is going to be a big problem for us, right? Uh, So this makes it a deterrent to use at the present moment hydrogen as a fuel. We are trying to find solutions to it. What we do is that we convert hydrogen gas into liquid hydrogen, so that is going to occupy less volume. We are also using metals as metal hydrides, which are going to uh, absorb hydrogen on their surfaces and then release it whenever it is required, so they can also be used as a storage and transportation media. But the problem is that when we are storing it this way, well, these alloys, these metals, they are very costly. So the expense part of using hydrogen as a fuel, that this becomes a deterrent, right? So as far as all these choices are now concerned, this is going to be correct choice. It is going to cause less pollution than petrol. This is also correct that it is going to weigh much more, so it is going to be a problem as far as storage and transportation is concerned. It is stored in tanks of metal alloys like sodium nickel alloy. It is stored in titanium hydride alloy, magnesium hydride alloy. So all these alloys, they are expensive. And on combustion, this is a false statement. Liquid dihydrogen is producing 142 kilojoule, and LPG, this is producing 50 kilojoule per gram of energy. So the correct choices over here, they are going to be A, B and C, and hence the choice is going to be D choice. Okay, I hope this is all clear. So that is as far as my 7 lectures from the course hydrogen is concerned, and there are going to be 7 more lectures in that course, making it a total of 14 lectures. And therefore, the lecture 2 is going to consist for this crash course. We will be covering water, heavy water, and hydrogen peroxide. So I hope you like the lecture with all these MCQs. You have been doing some problem solving also and learning hydrogen as well. Now, before I leave, there is going to be certain things that I would request you all to do. First of all, you have to attempt all these questions. You have to understand them. In case there is any doubt, you can put that in the comment section. You can also mail them to us at h2ochemistry@gmail.com. And also, you have to give me your feedback, how you like this lecture, right? So we are planning to put all the inorganic chapters like this, but it is going to be only when I will be receiving some feedbacks from you that you are liking this lecture, you're gaining from them. It is only then we will be putting more of these lectures. So please do subscribe to the channel, put your feedbacks. Thank you and have a nice day.